All right, in this problem we're going to prove that given a function f with domain D and target T that has subsets A and B of the domain, that if A and B if A is a subset of B, then the image of A under F is a subset of the image of B under F. Right, now here I have it drawn. You can see I have my function f from domain D to target T. A and B are both subsets of D, and A is a subset of B. A is in red, B is in blue. Okay, now the idea with this proof is that we're going to start with some y value over here, and we're going to say, hey, because y is in f of A, and f of A, sorry about that, is all the f of x values, f of x such that x is in A. Now this is its definition, right? So if y is over there, there's got to be some x over here that comes over to y. Okay, so we're going to start with y over in f of A. We're going to say by definition there's got to be some x in A that comes over to it. Well, since we assume the assumption A is a subset of B, well then x must also be in B. Okay, well that means that that f of x is in f of B. Well, f of x is equal to y, so that'll put y in f of B. All right, so that's our strategy. Now remember, when we're trying to prove that f of A is a subset of f of B, what this really means that if x is in f of A, then x is in f of B. So we're trying to prove this statement. Remember, to prove this statement, we can make this assumption. Now, it doesn't make sense to use x's because f of A and f of B live over in the target. And we think of, x, y, right? When we do like x, y, this is the domain, this is the target. So it makes sense to actually use a y here, just because we're used to thinking of y being something that happens in the range. Okay, so we're going to prove this statement. If y is in f of A, then y is in f of B. Okay, so we're going to say let y, oh, okay, that's right. Usually we say assume in this class, that's right. Same thing to say let. Assume y is in f of A. Okay, since f of A is the set of all f of x, such that x is in A, and y, let's see if we can say that, even, and y is in f of A, that's our assumption, right? So we'll get rid of the comma there. Ooh, didn't know you could do that. Okay, so assume y is in f of A. Since f of A is the set of all f of x, such that x is in A, and y is in there, y equals f of x for x in A. Now, since A is a subset of B, x is in B. Since A is a subset of B and x is in A, x also has to be in B. Okay, let's say since f of B I'll move this down one line, run out of room here. Since f of B is all of the f of x's such that x is in B and x is in B, f of x is in f of B. Now notice what we have above, right? We already said that y was equal to f of x. So, or maybe I'll do a since again. Since y equals f of x, y is in f of B. And that's the proof.